Guys, thank you so much for joining. I know it's a Saturday morning for some of you and it's Saturday evening for a lot of you. And I really appreciate you taking the time and joining this webinar. So thank you so much for joining. A little bit of introduction about myself. My name is Patrick. I'm one of the lead course creators at HadoopandRealWorld.com. Okay. How many of you guys know about Hadoop and Real World, and how many of you guys are students of Hadoop and Real World? Why don't you chat? Okay, student, perfect, perfect. And also, while you're doing that, can you also let us know where you're from? Because we would like to see, the participants. Where are you really from? We are from Chicago. So you got students from Bangalore, USA, Milwaukee, Turkey. Excellent. Okay, I think this is the first time we have someone from Turkey joining our webinar. That's awesome. Hyderabad, Bangalore, Serbia. Okay, that's new. Toronto, Canada, London, perfect. Okay, Mumbai, Tamil Nadu, Hyderabad, Pune, wow. Okay, so we got a lot of people from India. We got a lot of people from US, Poland. Okay, so that's the first. That's the first. Excellent. New York, Vietnam, perfect. Okay, student, Oman. Okay, excellent, excellent, perfect. That's awesome. We got close to 90 people in the webinar. That's really awesome, guys. That's really awesome. All right, so so we got students, and we also have some new people, in the webinar who may not know about us. So I'll just give you a quick introduction of who we are and what we do. Okay, so we are a group of Hadoop consultants, and back when Hadoop was not popular, we started working with big data / Hadoop. Right, we didn't have a lot of help, so we kind of most of the things that we did, we learned by ourselves, right? So as the technology was getting popular, we were doing consulting for several clients, and we wanted to build big enough teams. So we would hire people, we would hire qualified engineers or software developers, and we would train them on Hadoop, right? The training, what we were giving was not textbook style training. It was more hands-on, real world, solving real world problems kind of training, right? Basically what we wanted to show our new recruits, what are the problems we are facing and how we are solving them, okay? So, we were doing those training back like 6-7 years ago, and it was more like classroom style of training, and it was getting exhausting. So we recorded few sessions. We recorded some of our actual training sessions, and we then posted on our, on the portal on the client side, right? And then a few years later, we were going through some of the, we were trying to send our recruits to some of the online courses that were available, and we found out those were really, really horrible, right? They were mostly, textbook style training, mostly instructors reading off of a textbook. And the student on the other side couldn't really grasp the technology in the way that is being used in real world. The students are not exposed to the real world problems. It was basically telling what the software is doing instead of saying like how the software is basically used in real world, right? So we clearly thought that's not going to, that's not going to work. And what we had, that is the training that we were providing our students, were much more higher quality, right? So we decided to, just test it out, and we posted one of our courses online, and we got great response, right? So that's how HadoopandRealWorld.com was born, back 3-4 years ago, right? So since then, we started in Udemy.com, but now we have our own website. And across all, Udemy and our website, we have over 100,000 plus students, and that's unbelievable, right? The last time we did a webinar, I think that the count was somewhere around like 65,000. But since our courses are online, we have about 100,000 students across all our courses. And that's pretty unbelievable, right? And we love our students, right? We know why our students are coming to us, for to learn big data technology. We know what their focus is. We know what their goals are. So we are able to tailor the courses specifically for those who are looking to learn and excel in this technology, okay? So, if you're a student of us, thank you so much. Thank you so much for being a student. We love you. So thank you for sticking around. Okay. So what are the courses that we have, and where can you get, enroll in our courses? So I'm going to start with that before I'm going to start with the webinar. And today we have a, packed webinar with a lot of questions, right? With a lot of questions and a lot of interview questions and answers. Questions that were asked in real interviews and answers that are, that can be said in real interviews that will get you the job. Okay. All right. So we got 100 plus students. So where can you go to enroll in our courses, and what are the courses that we currently have? Okay. So we got 3 courses in Hadoop, right? We got Hadoop Starter Kit, which is a free starter kit course which will get you started in Hadoop. And then we got a full-on course for developer in Hadoop. And then we got a full-on course for Hadoop administration, right? And then we got 2 courses in Spark, Spark Starter Kit, which is again a free course which will get you started in Spark. And the other one is Spark Developer in Real World course. And you can enroll in all our courses in courses.hadoopinrealworld.com, right? Right now, you can enroll and start learning right away, okay? We also have the Hadoop Starter Kit, the Spark Starter Kit course, and the Hadoop Developer in Real World in Udemy. But the rest of the courses are only on courses.hadoopinrealworld.com, and we don't plan to include those courses in Udemy, okay? Because we get that question a lot, so I like to clarify that, right? As you can see here, we focus on big data and nothing else, right? Most of the places that you might have encountered, you probably saw those institutions have about 30, 40 courses in their catalog, right? We don't do all that, right? We focus on big data, and that's our focus, and that's our specialty, right? And this is how this is going to stay, right? You won't see us introducing courses in, I don't know, SQL Server or Oracle or something crazy like PMP certification. No, we won't do all that. Okay, so we are big data focused, and that's our specialty, that's our expertise, and that's where we will focus. Okay. All right, so with that introduction, let's get into today's webinar. What is the agenda for today? We are going to talk about some serious big data interview questions that were asked in real interviews, right? And I'm going to walk you through with the answers for each one of those questions. All right. Okay, so we did a similar webinar. We did a similar webinar about a year back, and you can find that webinar, the full recorded session, about 1 hour and 24 minutes in YouTube, right? So if you go to our channel, Hadoop in Real World, you will see that video. That's the top video there, okay? So you can watch that video in your free time, right? And we covered a lot of questions. So, so this webinar is happening because of that webinar, because once we did that webinar, and that was a year ago, almost exactly a year ago, right? And we got so many emails from our students and from members of the community in Hadoop and Real World asking to do a very similar webinar, right? And we were extremely busy this year with our Spark Developer and Real World course and all the updates we were doing to our courses. We couldn't do a webinar sooner, but we are happy we're able to do this webinar today. Okay, so if you're interested, check out that webinar. If you have not seen that webinar, I would certainly encourage you to do so. Okay, and it's in our channel. You can find that webinar at the very top, right? And these are some of the questions that were answered in that webinar. Okay, in the past webinar, I mean. Okay, so explain your real-time project roles and responsibilities. We answered that. We answered the MapReduce flow in detail, meaning how the shuffle works in detail. We answered, how many mappers and reducers will be created for a job, assuming you have a 10 GB data set, right? We answered how does a data set transfer from mapper to reducer. Again, we talked about the shuffle here. And we also said if you have one reducer, how does the data get to the reducer? Again, we're talking about shuffle. Okay, so a lot of good explanations on shuffle in our past webinar. The next thing we spoke about was when to use Hive, when to use Spark, Hive, what is the support for Hive with respect to ACID and CRUD operations, and when to use partitions, when to use buckets in Hive. A lot of questions were covered in Hive. So last webinar, so these are the questions coming from our students, right? Our members in the community. These are the real questions asked by an interviewer to one of our students in the community, right? So these are not like made up questions. These are questions coming from our students. So you can see a pattern in our last year's questions. There were a lot of Hive related questions, right? And a lot of Hadoop related questions. So some more questions in Hive. What is map side and SMB join in Hive? When to use columnar format and row format? And then what is the difference between RDD and DataFrame? So in last year, we got a lot of Hive questions plus, little bit of questions on Spark, okay? Not a too much question on Spark. So some more questions related to other tools in the ecosystem like Oozie or Flume or Sentry, Kafka, etc. And finally, how do you promote code to production? Why do we have odd number of nodes whenever there is an ensemble setup like Zookeeper? Is it possible to make mapper multi-threaded, right? So a lot of questions on Hadoop kind of tools, and a lot of questions on Hive, some related to optimization, not too much on Spark. Okay, so this time when we asked the same question that we published, we posted saying that we're going to do a webinar and it's going to be about big data questions and answers. So like last year, send me your questions. We got a lot of questions on Spark. Okay, we got a lot of questions on Spark. Okay, and we are going to cover a lot of questions on Spark, and we're going to answer and we're going to answer them. So that's a shift that we see in the technology landscape, right? So so from Hadoop to Hive to Spark now. Okay, so next year when we do a similar webinar, I don't know what the new trend will be, right? So we have to wait and watch. But the point I'm trying to make is, the ecosystem, the big data ecosystem is constantly evolving, right? And it is going to evolve, so we need to be on our toes, trying to learn as much as we could. Okay, so I see some people raising hands. I think, I'm sure you got some questions going on here. So I will, towards the very end of this session, I'm going to break for questions, okay? And I want to make sure that everyone is able to hear me, because I have someone saying the sound is not clear. So can everyone hear me okay? Okay, perfect. All right, so that's excellent. All right, so perfect. Okay, so let's get started, okay? So this is webinar part 2 of Big Data Interview Questions and Answers. All right, so the first set of questions that I have is, how do you handle scenarios when Spark runs out of memory? How Spark performs operations and generates results when dataset does not fit in memory? What do you do when one of the tasks in your Spark job fails with out of memory error? So as you can see, there are a lot of questions, from different people asking, the interviewer is asking, trying to ask the same thing, because this is a pain point in Spark, right? Spark is a big data environment with lots of nodes in the cluster. It's a memory intensive distributed system, right? With access to several GBs of memory, but yet jobs running in the Spark cluster fails with out of memory issues, right? So we got a lot of questions related to this. So let's see what the answer is. Okay. So the answer is quite lengthy here, and I'm going to give you a full-on explanation, right? And then you can the more information you give to the interviewer, the better chances are you impress the interviewer, right? No interviewer ever said, you gave me so much information, you need to give me less information. No, right? So when you're in an interview, you need to showcase your knowledge. That's the point of the interview. So more information you give the interviewer, the better. Okay. So when your Spark job is failing, you first need to identify what is failing, right? So what is a Spark job? A Spark job is made up of driver and a set of executors, right? Both are, both drivers and executors are JVM processes, right? And they both use a large amount of memory, and they both are allocated a certain finite amount of memory, right? And when both these driver and executors use more than what is allocated, we get out of memory. right? So that's why we get out of memory. So when you first receive a job failure, you need to first see what kind of failure it is. You need to see whether the driver failed or the executors failed, or the task inside the executors are failing. The task in a Hadoop job, the Spark job is divided into several tasks, right? And these tasks are run inside executors. You can think of executor as a container, with some CPU and memory allocated to it. So there are several jobs that can be executed in parallel inside a given container. And like that, for a Spark job, you would have X number of containers. A Spark job can have access to like maybe 10 or 15 containers. Guys, give me 1 second. I'm going to do a quick mute here because I see some people are not muted. All right, perfect. So the tasks run inside these container, right? So we need to understand what is failing. Is it the driver? Is it the executor? Or is it the task inside the containers fail? When you see a failure, don't always assume it's going to be out of memory, right? Even though out of memory is so common in Spark, but it's not always out of memory. You probably have another runtime exception, which is not out of memory, right? Probably you have bad code, which is causing a runtime exception. Right? So it's not always out of memory, but make sure if you're dealing with an out of memory issue or not in the very first place. Okay, so it'll be very clear if it's an out of memory. You will see it in the logs. You will see errors such as out of memory exception or the container being killed. That's another error that you will see, which indicates the process is being killed because the process requested more memory than it is allocated. Okay, so first identify the failure, make sure it's out of memory, right? Next, so I said there are two key components, right? The driver and the executors. Driver is actually orchestrating the execution between the executors, okay? And driver has a set of memory, and each executor is assigned a certain amount of memory for execution. And you can control both the memory with Spark executor memory and Spark driver executor memory, okay? Most often you would see memory issues with executors and not with reducers. Okay, sometimes you would see issues with drivers too, but less common. More often than not, you would see issues with executor going out of memory. Or task running inside the executor running out of memory. Those are the usual issues you would see, right? So you can control the memory allocation for executor using Spark executor memory. So the first thing you could think is, okay, so let's say your executor is already assigned 20 GB of memory, okay? So your executor is going out of, your executors or the task running inside the executor running out of memory, which would mean you could say like, I'm going to give more memory to my executor. Will that fix my problem? Maybe it will, or maybe it will not, okay? It depends on what the problem actually is. You need to identify the root cause, right? So, you can, if you feel your executor or your task inside the executor is struggling for memory and the executor is not assigned enough memory, by all means, you can increase the amount of memory, okay? By all means, you can increase the amount of memory. But you need to understand the memory architecture inside the executor before you can do so, okay? So you have to understand how the memory is organized inside the executor. Okay, so let's say you have 4 GB of memory allocated to your executor, right? 300 MB of that 4 GB is reserved, okay? Spark reserves it. You don't have access to it, right? And the 60% of the rest, that for 4 GB minus 300 MB, and 60% of the rest goes to Spark. We call it Spark memory, right? 60%. So that can be tweaked. You can adjust that with Spark memory fraction parameter, okay? So 60% of that goes to Spark, and the rest will go to the user memory, okay? The rest will go to the user memory. All right. The Spark memory is the very important one because this is the memory maintained by Spark for two things, for storage and execution, okay? Storage is where the objects that you're cached that are going to reside. Okay, the objects that you cached will reside in the storage. Execution memory is used by Spark for execution. Okay, this is used during shuffle, aggregation, any kind of wide transformation or narrow transformation. This is the place where Spark put the objects that are being currently executed or needed for execution, right? When you say out of memory, it is usually because Spark doesn't have enough execution memory, okay? So if you're using Spark version less than 1.6, I would ask you to check your allocation to Spark Shuffle Memory Fraction Parameter and Spark Storage Memory Fraction Parameter. Because Spark Shuffle Memory Fraction Parameter controls the execution memory and Spark Storage Memory Fraction Parameter controls the storage memory. Okay, so there are two parameters. This is before Spark 1.6, but most production environments are past that point, right? Because prior to 1.6, Spark used a memory allocation called static memory allocation, okay, or static memory manager, right? So with that, both the storage and the shuffle or the execution memory are static. Whatever you define at the time of creating the executor, that's what both executors, the execution and storage gets, right? They don't have any wiggle room. But after 1.6, Spark introduced dynamic memory manager. Okay, so execution memory and storage memory are dynamic within the Spark memory boundary. Okay, so let's say you're storing a lot of objects. So initially both gets 50-50 of the Spark memory, right? So remember, 4 GB, 300 goes to reserve, 60% goes to Spark memory, which is 2.2 GB almost, right? After 2.2 GB, by default, storage memory gets 50%, which is 1.1 GB, and execution memory gets 50%, which is 1.1 GB, right? That's how they start. But let's say for execution, you're going beyond 1.1 GB, right? With the new dynamic memory manager, that is after Spark 1.6, it is totally okay, right? The execution memory will start using the memory that is free in storage memory, right? So if the storage memory has enough space left, execution memory will take it. What if the storage doesn't have enough space left, right? Again, Spark, what it will do is it will take the objects from the storage, that is from the cache, and it will move it to the disk, okay? So it will move the objects, it will evict from the memory to the disk, okay? And it will expand. So Spark always gives preference to the execution memory. Okay, so whether the storage memory has enough room or not, it will make room for execution memory. Spark will always make room for execution memory, right? Same with storage too. So let's say we are not utilizing the execution memory, and we have a lot of execution room and execution memory, but Spark is in need of storage. It's in need of caching, right? Then storage memory will go beyond the 1.1 GB if needed, provided execution memory has enough room. If execution memory is already fully utilized, Spark will say, no, storage, you cannot expand anymore because I cannot evict anything out of execution, so you need to write it to the disk, okay? So Spark will give priority to the execution memory. All right, so Spark will give always priority to execution memory because you cannot evict things from execution, right? Because those are being executed, and Spark has to maintain those objects that to do a smooth execution. Okay, so memory management is more dynamic, but you need to understand how you're allocating this, right? So storage memory by default is controlled by Spark memory storage fraction, and by default it's 50%, right? If you feel you need more execution memory, make it 40%, right? Or make it 30% even. Give more room for execution. Remember, if Spark doesn't have enough room for execution, that's when you get out of memory, okay? That's when you get out of memory. Because storage can always be evicted from memory and returned to the disk. Spark cannot do the same with the execution memory. So if you feel you're going to have a lot of objects in your execution memory, please, reduce the storage fraction to make it like 40% or 30%, right? Okay, as a default, all right? So understanding the memory allocation helps helps you design your jobs better, right? But that's just one piece of the puzzle. Second, you need to know how many CPU cores you have, right? How many CPU cores is allocated to each executor, right? So let's say you have allocated 2 CPU cores to each executor. What that means? That means you can execute two tasks in parallel inside that executor, okay? Which means you can do 2 tasks in parallel in each executor, right? So number of CPU cores means number of tasks that can be executed in parallel, okay? So you need to be smart about deciding your number of tasks, because number of partitions decides your number of tasks, okay? So if you have a big enough data set, and that data set, let's say it's divided into 100 partitions, which means Spark will create 100 tasks for that job, right? So if each task has to deal with a lot of data, let's say, each task has to deal with a lot of data, you have a potential problem of getting out of memory, because each task is overloaded, right? Each task is overloaded. So few partitions meaning fewer tasks, which means each task can be overloaded, which can cause out of memory issues, which is something you want to avoid, okay? So a good rule is, for each CPU, you can assign at least 2 to 3 tasks, okay? So prepare your job and prepare the number of partitions like that, with that in mind, okay? So that's kind of a baseline. That's kind of a good guideline, right? For each CPU core, you can go with 2 to 3 tasks. Okay, so fewer partitions, you will have a problem, okay? The next one is unbalanced partition. And this is, this symptom is when you see, almost all the tasks, let's say you have 100 tasks in your job, right? And 99 tasks could be done in like few minutes. And then you have this one task running for like 30, 40 minutes. Why that's the case? Because you got unbalanced partitions. Meaning like one partition, which has a lot of data. So this task dealing with that partition has to do too much. Okay, and this is common with poorly created XML files or highly nested JSON files. Okay, highly nested JSON files, because you can have a JSON document, and if you have a lot of nesting in that in the document, certain the JSON documents can have more number of records inside the nesting than the others. Same with XML, right? So you got disproportional partitions, right? Because the record can actually span between partitions, right? So that creates like unbalanced partition, causing you out of memory errors with tasks. So you need to keep that in mind, right? So before I move on, so those are the common out of memory issues, right? So those are the common things that you can check to see whether how to address out of memory issues. Make sure you know your parameters, make sure how your memory is structured, right? And then see how much CPU you have access to, and make sure you design your number of tasks accordingly, and make sure you don't have like fewer partitions, meaning like it would result in overloaded task, and make sure you got unbalanced partition. Make sure your partitions are nicely evened out. Okay, so that should solve most of your issues with respect to out of memory. Okay, so now let's move on to the next question. Okay, how do you handle slow running jobs in Spark? What do you do when one task takes a lot of time in your Spark job while others complete in time? Tell us some of the Spark optimization techniques you implemented in your current job. Okay, so this set of questions, right? Again, I can see an interviewer asking the first question, that is, what do you do about failures? And the second question about optimization, like what we see here, back to back, right? Because these are the common problems that you see in a big data setup. It doesn't matter you're using Spark or just plain old MapReduce, you're going to see these issues, right? Things running, things that doesn't run, meaning errors out, and things that runs but very slowly. So now we're going to talk about what do we do about slow running jobs? How do we optimize them in Spark? Okay, all right. Spark performance tuning. File formats, right? So keep Spark aside. Whether you're using MapReduce or Spark, choose good file formats. So if you're working with JSON data and XML data, those are not like great file formats to work with because they don't have any kind of optimization built in or any kind of intelligence built into these files. But instead, if you have data stored in Parquet, or if you have data stored in file formats like Parquet or Arc, you're going to get much better performance. Doesn't matter what execution engine you're using, right? Whether it's MapReduce or Spark, you're going to get better performance, okay? So the first thing is choose your file formats, because that's the source for any execution platform, right? So why do you want to choose a suboptimal format, right? So choose your file formats properly. Next, choose your operations wisely, okay? So for example, you need to choose, Spark has given you a rich set of APIs to work with, a rich set of functions to work with, right? Each function can do slightly different things. They would look like they're doing the similar thing, but internally they're doing it in different ways, right? Which can cause difference in execution times and in, again, performance, right? For example, I'll give you an example. Take reduce by key and group by key, two RDD functions, reduce by key and group by key, right? They pretty much do something very similar, but again, their implementation, the internal implementation are very different, okay? So reduce by key, how does reduce by key work? Right? So reduce by key, again, it is reducing the similar MapReduce concept. It is reducing all the values by key. But reduce by key something does something which is optimizer friendly, right? It can do map side aggregation. Reduce by key does map side aggregation, or we call it map side combine, before it sends the data to the reducer, meaning less data to shuffle, meaning less data to transfer to the reducer, okay? So meaning faster execution and less utilization of your network bandwidth. Group by key, on the other hand, does something very similar. It groups by key, right, as the name suggests, but it doesn't do map side combine. So which means if you got 100 key value pairs, the 100 key value pairs will go through a shuffle process and it will reach the reducer, meaning your shuffle process becomes expensive, and also you're utilizing a lot of network bandwidth. Okay. Another good example is coalesce versus repartition. Anytime you repartition the data, it is going to be slow. By repartition, I shouldn't say slow, but it is an expensive operation, right? You're sorting, you're shuffling, you're doing a lot of things. Okay. So repartition is nothing but coalesce in the back end, right? That's the back end call. So repartition calls the coalesce function without shuffle, right? Whereas coalesce has the ability to do repartition with and without shuffle, right? If you're trying to reduce the number of partition, I would use coalesce with shuffle equals false, right? So knowing how you can manage it, how you can use these functions would definitely help. And also knowing the behind the scenes details of these functions certainly help. So if you see two functions doing the same thing, don't pick just one over the other randomly. See what it is doing before you pick one function over the other. Okay? All right. So that's choose your operations wisely. What is next? Use partition techniques. So what I'm going to tell you is this is very interesting, and this will save you a lot of trouble, and most likely, the interviewer will be satisfied with performance tuning after you say this, okay? So use partition techniques. So I have a small piece of code here, right? We are creating two RDDs and we're joining the two RDDs here, right? Nothing fancy. And this is how this is going to turn out, in the execution, right? So first a co-grouped RDD will be created. So this is the behind the scenes RDD that gets created. And to create the co-group RDD, you can see a shuffle is in play, right? You have two stages, stage 1 and stage 2, and then a shuffle, which results in stage 3, meaning whenever you do a shuffle, you are doing sorting. Even though the sorting that's done, even though the shuffle operation in Spark is a little bit better than what happens in MapReduce. And by the way, we have a full chapter on shuffle in our Spark Developer and Real World course, okay? So the shuffle results in a wide transformation. It transfers a lot of data into co-group RDD and to the map partitions RDD, right? And finally, you do the join. Okay, finally you do the join. So you can be a little bit smarter here and partition the data. That is partition RDD1 and 2 by the same partitioner. Okay, so here the same thing. I have RDD1, but I'm partitioning the RDD1 using the hash partitioner, and I'm setting the number of partitions to 2. Similarly, I'm partitioning RDD2 using hash partitioner again, the same partitioner that I used with RDD1, and I'm also setting the number of partitions to 2, which is the same number of partitions as RDD1. Okay, and then I'm performing a join. Okay, so this you see here, this shuffle operation is the result of partitioning. Okay, it's not the result of join. Very important to understand. It's not the result of join, it's a result of your partitioning. So again, this shuffle right here is the result of the partitioner on RDD2. Okay, then you're doing the join, and this is not a shuffle. You see, the data is being transferred inside the same stage, right? This is not a wide transformation. So this cogroup RDD is created by just copying these two partitions. That's it, right? It doesn't happen as a wide transformation. Okay, so with this join right here, right? So this portion right here, we avoided a shuffle, and that is good because no shuffle means you're not transferring data, you're not sorting the data, and your executions are going to be faster. Shuffle is the slowest operation in the chain, and anytime you find a way to avoid shuffle, it's great. Okay, so executions are going to be faster. Some of you, I know what some of you are thinking. Some of you are thinking, okay, I understand I'm not doing a shuffle during the join, but I'm doing a shuffle during a partition. How this is any better? No, that's a good question. That's a valid question, right? That's a valid question. But remember, once you partition your data set, you are not going to do a shuffle anymore after that. You can do several transformations on that RDD and not do a shuffle, right? And also this shuffle is being done within RDD1 and RDD2, not against RDD1 and RDD2, right? So this shuffle is going to be better than the full-on shuffle between two RDDs across. Okay, but the most important benefit is you shuffle once, that is you partition the data once, and you're going to use the partitioned RDD several times after. Okay, so that's the benefit, right? You avoid shuffle using partitioner techniques. Here I have used hash partitioner, right? You can also use range partitioner, or you can write your own custom partitioner. Okay. All right. There are a couple more things that I wanted to talk about with respect to performance tuning. One is broadcast variables and cryo serializer, right? Broadcast variables allow you to broadcast a certain amounts, a set of data to all the executors and cache the data in the executor, right? So let's say you have 100 tasks, right? And you need to send a table, or you need to make a table available for all these 100 tasks. There are two ways you can do this, right? One, you can for any time you execute a task, you can send this table to the task. So that is passing the table over the network 100 times, right? Or what you can do, let's say you have 10 executors executing all these 100 tasks, you send this table to all these 10 executors and let the executors cache this table in its cache. And any task executing in these executors can read the table from the cache, right? So this is awesome, right? Because you're not sending the table 100 times, instead you're sending the table 10 times and let the executor cache the table. So you can leverage broadcast variables to do this. And next is cryo serializer. What is cryo serializer? Spark serializes a lot of data, okay? So the serialization happens during shuffle. The serialization can happen if you're serializing your RDD when you're doing caching. So instead of using the default Java serializer, which is slow, and when it serializes bulky objects, okay? The objects that are getting serialized in by default Java serializer are usually bulky, right? If you use something like a cryo serializer, not only it is fast, it will also save you some space. Okay, so cryo serializers are definitely faster than the counterpart Java serializer. Okay, so these are the common performance tuning things that you could do. Okay, so let's just recap the performance things that we saw. Okay, there's so many slides here. Okay, so choose your file formats and your operations wisely, right? More intelligent file formats, meaning the file formats will give you a lot of performance improvement on the Spark execution. Next, use partition techniques, right? So when you partition the data, you're avoiding shuffle. And finally, think about using techniques like using broadcast variables or cryo serializer for faster and a more lighter serialization. Okay, all right. Next, again on Spark. So another question on Spark streaming. Okay, so this time Spark streaming. And this is an interesting question. And for sure, we're going to use this question in our interviews too when we interview candidates. How do you handle Spark streaming failures? What happened to Spark streaming when there is a network failure during processing? Another flavor of this question, how do you recover from Spark streaming failures? I mean, all three questions point to the same thing. You have Spark streaming, and how do you recover from failure? Okay, so what is Spark streaming? So far, with MapReduce and when Spark first came out, it was all batch processing. You have a file sitting in HDFS or another reliable storage like S3, whatnot, and you have jobs executing against these data sets, right? So that's batch processing. But nowadays, what's happening, with this with so mobile-friendly environment that we have, right? We have mobile watches, we have mobile systems, we have mobile, cars which are digitally hooked to the internet. There's so much data flowing through the data waves, right? And the infrastructure that we have on the other side is receiving so much data. And what you can do with so much data coming in at real time, you can store it and you can process it in an interval fashion, like end of day or every hour, whatever, right? Or you can process the data as the data is coming in. That is called streaming. That is called stream processing, right? So you don't accumulate the data and then start your processing. As the data is coming in, you start processing. You save time and you get up-to-date information, right? So that's exactly what you want in this day and age, right? You want to stream the data, calculate the data as the data coming in. Okay, so here is an example, right? So here, our Spark cluster is streaming data from a Kafka cluster. Kafka is a message broker, right? It's a distributed message broker, and it is a low latency system, meaning it can send hundreds or thousands of messages, in a millisecond, right, to a Spark cluster. And executors, you have receivers, you have Kafka receivers receiving these messages, right? And before these messages can be processed, they will be held in memory, right? And then the driver will allocate the executors to what to process, right? It will send like jobs to process, okay? But they will be in memory. They will be in memory for a while. So the executors will hold data in a memory for a while. And as it is being processed, it will be returned to think of it as a table, right? As a giant table, an ever-growing table, right? So that's where the output is. It's going to reside. I'm making this more, simplified, but you can think the result is being returned to a giant table, which is ever-growing, and it's infinite, right? So what happens when an executor goes down in this environment? Right, so driver, who is the orchestrator of the streaming job, will notice the executor failed, and it will kick off another task in another good executor. Everyone is happy. But what happens when a driver failed? Right, a driver failure is more serious because when a driver fails, it will take down the executors along with it, because there is no one to orchestrate the execution, right? So what happens? How do we recover from such failure, right, in a streaming environment? So this is what we will do. So Spark introduced this, the recovery capability to a streaming application using write-ahead log, right? Write-ahead log is a well-known concept. It is used in pretty much all the NoSQL systems out there. Not all, but most of them, at least, right? First, as the executors are receiving the messages, it will be stored in the memory, right? And once it's stored in the memory, it will be sent to HDFS. Okay, HDFS or S3, any reliable storage system, or even a database for that matter, right? It will first have it in memory, and then it will write to a log. Where it's being written, it's like it's a safe, reliable storage like HDFS or S3, and then it will be sent to the driver for checkpoint, saying like, I have this data, and this is the data I have processed, and this is what I have, right? Once this is done, an acknowledgement is sent by the executor to a Kafka cluster saying that I received this message, okay? I received this message, it's safe with me. Even if I go down, my Spark driver knows that, this message is safely stored in HDFS. So even if I go down or my Spark driver goes down, both of us can be restarted, and since we know the last checkpoint or the last message that was processed, we can start from where we left off, because the message is now safely stored in HDFS. And we are also tracking, the Spark driver is actually tracking what message was processed and where these messages are saved in HDFS or S3. Okay. So recovery is possible because you're writing to reliable storage called, write ahead log or WAL, right? And a checkpoint is being maintained. Right? So what happens if you receive the message, right? But how does a Kafka knows that it needs to send back something, right? What if something happened, the message left Kafka, right? But an acknowledgement wasn't sent, right? Meaning the message was not written in the write ahead log, right? What happens then? Since the acknowledgement is not sent, systems like Kafka can resend the message back. Okay, so that's why that's how we safeguard against failure against each system in the chain, and also we can recover end to end. Okay, so that's how we recover from Spark streaming failure. Okay. Next question, again Spark. What is the difference between data frame and dataset? When do you use data frame and when do you use dataset, right? So to answer this, we need to see how both data frame and dataset would look like, right? So here I'm defining an RDD, then I created a data frame, okay? So I've taken my RDD and I've converted the RDD to a data frame. I've named it 2 columns, department and salary. The first column is department and the second column is salary, right? And then I'm doing a filter. Filter department equals ID, and then I'm doing a collect. So this is going to list the records with department IT. So this is how I do it in a data frame. Okay. Again, I don't need an RDD to create a data frame. I just have it. But we don't need an RDD to create a data frame. Okay. Okay. So let's see, how do we do the same thing with the data set? With data set, we have a class. We have a case class, and this is Scala code, by the way. We have a case class with department string and salary long, 2 columns, right, or 2 properties. And then using a data frame, I've created a data set. I'm saying data df, which is my data frame, dot as department. So here you can see I have created a data set with type department. Okay, it's a domain specific type, right? So before, I created a data frame. I created a data frame with no specific class or no specific type. Okay, internally, but with data set, I created with a specific type, which is of type department. Okay, so internally, both data frame and data set actually points back to data set. Okay, a data frame is nothing but data set of type row. Okay, a data set, this data set right here is of type department. That's the only difference, guys. Okay, a data frame is data set of type row, and data set is the type that you use to create. In this case, it's going to be data department. Okay, so that's good. From the theory perspective, that's excellent. Okay, you can do pretty much all operations that you do with data frames with data set, because a data frame is actually a data set behind the scenes of type row. right? So you can do pretty much the same operations that you do on both. So what is it? So why do we need, why do we need this differentiating factor, right? The differentiating factor comes with type safety. Okay, since data set is created of a specific type, that is the type that is created by you, this is going to give you compile time safety, right? Compile time type safety, to be very specific. Okay, so for example, here, department, here data frame does not know department is a string column. Okay, here the data set clearly knows department is a string column. So if you're trying to do a numerical evaluation on the string column, it's going to throw you a compile time error. Okay, so if you do department greater than 100, it's going to throw you a compile time error with the data set, not with the data frame. Okay, so it gives you compile time type safety. Okay, it's also going to give you a lot of referential errors and syntax errors at the compile time. That is data set. Data set is going to give you, if you refer a column which is not available. For example, if you refer a column employee name against a data set, you will get a compile time error. You will also get an error with data frame, but the error comes at the analysis time. Okay, the error comes at that analysis time, not at compile time. Okay, so here is a small chart to show that, right? So syntax error, data frame and data set both happens at compile time, whereas reference or analysis errors, such as types and things like that, will happen at runtime or analysis time, to be very specific, not runtime. Okay, analysis time. The Catalyst optimizer will does an analysis of your code, and that's when you get that error. Okay, and then data sets, happens at compile time. Okay, so that's awesome, right? You can see the errors as it's happening. All right, meaning before runtime. Before runtime. The other couple of things that you wanted to note is dataset is not possible with Python because Python does not support compile time type safety. Very important thing to note, okay? It's not possible with Python. It's possible with Scala and Java. And then dataset maybe slightly a little bit slower than data frame. Not too much, okay? Slightly a little bit slower than data frame because Spark has to convert the objects to your own specific user-defined type. Okay, it has to cast the object back. It's a slight delay, it's a slight slowness, but not too much. I'm not trying to exaggerate that. Just tiny bit. Okay, so keep that in mind. All right. All right. Okay, so we are moving from Spark to Hadoop, right? So how do you properly remove data nodes from your cluster? Just one thing. We scheduled this webinar for an hour, but looks like it is going beyond an hour. But I'm sure you're learning a lot. So we're going to move on, right? I have a few more very nice questions to answer, right? How do you properly remove data nodes from your cluster? Okay, so this is a Hadoop related question. All right, it's a very good question actually. So how do you do it? So we have asked this question to when we hire Hadoop administrators or developers in the past, okay? So sometimes we get answers like, oh, well, I'll just shut down the node. I'll just shut down the node, I'll kill the process and it will take care of it. Name node will take care of it, yes. As soon as you shut down the node, name node will see that the data node did not send a heartbeat, so name node understands something happened with the data node, right? And any blocks present in the data node will be marked as under-replicated, and it will be and it will replicate. That's good. So even if you shut down abruptly, name node will be able to handle that. But there are some issues with it, right? First of all, if you're decommissioning a data node, you're doing it for a very good reason, right? It doesn't have to be abrupt like that, right? So it has to be well planned and executed. And the second thing is, let's say you're shutting it down and most Hadoop clusters are monitored round the clock, and other administrator sees this data node is down and he can bring it back up again, right? And so why do you have to, how do you safely and systematically decommission a data node, right? So you can do that using these two property files, DFS host and DFS host exclude. Include and exclude file, right? So the include file will have all the nodes that are in the cluster, or that should be part of the cluster, and the exclude file will have all the nodes that should be excluded from your cluster. Okay, so now you know this, right? So how do you do it? How do you decommission the data node? Okay, you're probably thinking, I'm going to remove the node that I'm going to decommission from the include file. I'm going to add it to the exclude file, right? Okay, not right actually. The reason is, as soon as you remove the file from the include file, name node will deny any communication from that data node. Okay, so that data node will not be able to talk to the name node, which means, again, you're abruptly doing something, right? We don't want that. So what you have to do is first include the data node you're trying to decommission to the exclude list. Leave it in the include list, okay? And then issue a HDFS DFS admin refresh node commands. This command will not restart your cluster, so don't worry. Your jobs are fine, okay? The jobs that are running, they're not going to be interrupted. So you're fine there. So what the name node will do is it will read everything from the include. It will read everything from the exclude, okay? Since the data node you're trying to decommission is also in the include, the data node will still be able to communicate with the name node, so no problem there. Since this data node is in the exclude list, name node will mark this node for decommission, okay? So this is a very smooth operation. It will mark the node for decommission. So immediately in the name node web UI, you will see active nodes, and then at the bottom you have the decommissioning nodes. You will see this node in decommissioning, okay? The status will be decommissioning, right? So the blocks that are part of this data node will be marked as under replicated blocks, and name node will arrange replication for all those blocks, okay? So this happens nicely behind the scenes, okay? So you don't have to abruptly do anything, right? So this operation is very smooth. So once all the blocks are replicated, the data node will be marked as decommissioned. Good? So that's a smooth way of doing things. So once it's fully decommissioned, then you can remove the node from the include list and do a refresh nodes again. You're done. That's how you safely decommission a data node, right? And then you can turn off the data node process on this node, or you can even shut down the node. Even if an administrator saw this, so let's say you forgot to send out a notification that this data node is decommissioned. You just forgot, right? You had a busy day, you had a long day, you forgot. Another administrator, if he tries to bring up the node, name node will deny communication because this node is not in the include list. Then the admin would know, okay, this node, someone removed it from the include list. That's probably a very good reason why they did that, right? So, probably I missed a communication here. That's it, right? So that's a smooth way, a neat way of decommissioning a data node. Okay. And again, this we have a full-on chapter in our Hadoop Administrator in Real World course, and we actually cover this. We cover a lot of the things that we're going here in our courses, right? Because this is not the first time, so we are hearing this question. We ourselves as interviewers ask this question to other candidates ourselves, right? And we do this on a day-to-day basis. So we have a separate chapter called Day-to-Day Essentials in our Hadoop Administrator in Real World course, and this is one of the lessons inside that course. Okay, so this is not a new topic for us. Okay, next is securing Hive. How do you secure Hive, and how do you authorize users with Hive? Okay, how do you secure Hive, and how do you authorize users with Hive? Okay, so what is Hive first? For people who don't know what is Hive, Hive gives you table-like representations of your data on a storage, right? Like HDFS or S3. It lets you organize the data behind the tables in partitions or buckets so that you can efficiently process the data, right? And it also gives you structure for your data, right? Because with RDBMS, you have table structures, right? If you go to Oracle, you have nice rows and columns. Hive, but with big data, you have files, right? But it should be nice to visualize. It would be nice to visualize the data as a table because we're so used to tables, a row, columnar, structured way of looking at things, right? So Hive gives you that. On top of it, Hive also lets you to write SQL, and that SQL can be translated into MapReduce jobs or Spark jobs. Okay, so that's the idea behind Hive. First, it gives you a table-like structure for your files, And next, it gives you SQL access, SQL-like query access to your data, right, in HDFS. Okay. So there are two ways Hive is being used, right? One, you can use Hive directly, like using a Hive client or Beeline, right? Those are Hive clients used to access Hive. There is another style of access, which is like other applications leveraging the table-like structure that Hive provides on top of the data. Okay, so these are systems like Tez or Spark or Apache Pig. So these are basically using the Hive table-like structures, leveraging the Hive table-like structure to access the data, right? So in that case, you're kind of bypassing Hive, so to speak. Okay, so if you're doing that, you should think about storage-based authorization. Okay, and this is implemented by HDFS access control list, or ACLs or ACLs. Okay, so here you're defining access control lists for your folders and directories. Who should have access, what access they should have, whether they should have read, write, or execute permissions and such. Okay, very similar to your Unix permissions, right? So HDFS is going to drive the security. HDFS is going to drive the authorization of what users can see and not see, do and cannot do. Okay, so and this is done by the storage-based authorization. To enable this, you need to set the property Hive Security Metastore Authorization Manager to storage-based authorization provider. Okay, all right. So if you're securing your Hive, you can also, if you're using Hive Server 2, that is using Beeline or using a Hive client, the SQL standard-based authorization is also available for you. Okay, so you can use select, insert, update, delete on all privileges, like you would do it in MySQL or Oracle or MS SQL Server, right? You can write grants on specific tables, specific views, etc. And these are the grant types. You can allow select, you can allow or deny insert, you can allow or deny update, delete, or you can provide all privileges. Okay, and this is how you secure Hive. All right. Okay. Just a quick check here. Everyone is still following, right? I'm going to pause for questions, but everyone is still following, right? Okay. All right. I just want to make sure. It's been over an hour. I want to make sure you guys are still tuned. Okay. Perfect. Thanks, guys. Thank you. Thanks for sticking around. Thank you. Okay. So next question. Again, Hive optimization related questions. How do you optimize slow running Hive queries? How can you optimize a slow running Hive join query? Okay. All right. So for this question, I've already covered this question in our last webinar. Okay. So in the very first, I said, we have done the first webinar, and I have answered this question myself on that webinar, right? So focus on topics like the map join and the SMB join, right? So the answers are already given, for these two queries. But we got a lot of, similar questions, so that's why I wanted to include. I don't want it to miss. But if you're looking for an answer, go check our first webinar, okay? All right. Okay, so this is an interesting question. Provide an use case for Zookeeper. And what is the role of Zookeeper in a big data cluster, right? Zookeeper is mostly an afterthought, right? Because it's just sitting on the side of your cluster. No one really uses it, but people know it does something, but most people don't know what it actually does. It was set up when you set up a HBase or Kafka, and then you forgot about it, right? You did not really know like why you created it, but the documentation asked you to create it and you just did it. Okay, so whoever asked this, we asked this question because most people struggle to answer, but whoever asked this question, they wanted to find whether the candidate is paying enough attention to the cluster or not. I think that's what the interviewer is trying to get from that candidate. Okay, so it is an interesting piece of software. And let's see what the software actually does. Okay, Zookeeper. What is it all about? Coordination service for distributed application. That's what Zookeeper is, but I'm sure that doesn't mean anything to you. I'll go over things in a bit, right? It is used for leader election and automatic failover. So those are the two common use cases that Zookeeper is used for, okay? Leader election and automatic failover. Of course, there are several other benefits and functionalities of Zookeeper, but it is commonly used in like leader election and automatic failover, and it is a very common use case, right? So the Zookeeper is more like a tool to control the other animals in the zoo, right? The other animals being your other tools in the Hadoop ecosystem, right? So if you take any tool in the Hadoop ecosystem, like it could be Hadoop, or it could be Spark, or it could be HBase, you have a collection of nodes, right? You have a collection of nodes. So in these collection of nodes, most likely one node can do the actions of a master. The other can do the actions of a slave, right? So in such an environment, if all nodes are treated equally, how do you elect a master? And how do you say to all other nodes, you're the slave, you need to follow this master? Because they're all equal, right? So, and who is taking care of coordination between this? If everyone is equal, who is coordinating? Who is leading, right? And if the master fails, for instance, right, who is going to pitch in and become the master? Who is going to decide who becomes the next master? So Zookeeper provides such coordination capabilities to your Hadoop ecosystem, okay? All right. Okay, so let's talk about leader election. So in this, I'm going to talk about resource manager failures, okay? Resource manager failure. And again, in our course, we talk about resource manager, high availability in resource manager, high availability in name node, and how to protect your environment against failures using high availability and things like that, right? But let's strictly talk about leader election with respect to resource manager. So in Hadoop, you have this functionality called Yarn, which is nothing but a resource manager. It manages resources in your cluster, right? And Yarn has a component called resource manager, and several other nodes perform the node manager functions. Okay, so that's Yarn at a very high level. Now, you can have multiple resource manager, one acting like an active resource manager and other being in standby. So if anything happens to active, the standby can pitch in and help. Okay, so these two resource manager are exactly alike. Okay, so they're exactly equal, right? So how do you make one be the active and another be the standby? Who decide which one to be active and which one to be standby? Actually, we can let the resource manager decide or make the decision among themselves, okay? And this is how Zookeeper helps. So with Zookeeper, you can think of Zookeeper as like a file system where you can create folders and files, okay? So both resource manager, before they will try to become active, right? And the way they're trying to become active is by creating a file. I'm just going to, a name file, and files are called, you can think of file, actually nodes. I'm going to refer the terminology node, but when you say node, just imagine file, okay? So both resource manager will try to create a node called active standby electoral lock, okay? And the type of this node is called ephemeral node, all right? And only one is allowed to create it, right? So this active standby electoral lock node can be only one. So only one can create it. So once resource manager let's say resource manager 1 is successfully able to create it, right? When resource manager 2 tries to create it, it will be a failure, okay? And then once resource manager 1, creates this active standby electoral lock, it becomes the active node, okay? Whoever creates it becomes active, all right? And then resource manager 1 will create another node called active breadcrumb. It's another type of node, right? And it will write this information. It will say resource manager 1 is now active. It's now the active resource manager in the cluster, right? So resource manager 2 can read this node, that is the active breadcrumb, and know who is the active. That's the point of it, right? So the other node that is active standby electoral lock is called the ephemeral node, okay? The point of ephemeral node is if the node if the server which created this node died for some reason, this log file, that's the ephemeral node, will go away. Okay, Zookeeper controls it, right? Since Resource Manager 1 creates this node, for some reason Resource Manager 1 is gone, like lost a network connection or whatever, the active standby electoral lock will be deleted. Okay, and then Resource Manager 2 will be notified because Resource Manager 2 is watching this electoral lock file. Okay, being this ephemeral node, it's watching it. If it is gone, it will immediately go ahead and create it. Okay, since it created it, now Resource Manager 2 will become the master. Okay, 2 will become the master. So that's a very simple use case for Zookeeper, right? Leader election. That's a very simple use case. We also have another use case for automatic failover. You know, again, Zookeeper does automatic failover as well. But you know, we also have a blog post on this topic. So if you go to our website and type in Zookeeper, you know, you'll get to the same page. But in the interest of time, since we are going like 15 minutes past, I'm just going to skip this. But another good use case for Zookeeper is automatic failover on top of leader election. Okay. All right. Okay. So now another Hadoop question. How do you limit the number of files under a directory in HDFS, and how do you limit the space allocation in HDFS? You can do two things, okay? It's called quotas, and you can set a name quota and you can set a space quota. Okay, so the name quota gives you or tells you, excuse me, tells you the number of files you can actually create, the number of files and folders you can actually create. That's your name quota. And you set it on a folder by using HDFS DFS admin set quota. Okay. You can also set a space quota. You can say, for example, you can select a home directory of a user and you can say, this home directory should only have this much of space, 1 GB, right? And that's all he's going to get. So this is to put restrictions on the number of files someone can create and also the number of, the amount of space a folder can have access to. Right? In terms of storage, I mean, right? So name quota and space quota. All right. Okay. So far we saw a lot of questions, guys, right? So we saw a lot of questions, and you can see, you know, where our focus is coming from. And these are real questions as in real world interviews, right? And these questions are no joke. You know, no one is asking. Sometimes when I go through like interview questions, I come across a blog post where they say interview questions, right? And they ask questions like, what is name node? And you know, I'm speaking here for about, you know, close to an hour and a half, you know, and I did not cover the question, what is name node, right? Because no one is asking that question, that's why, right? And even, you know, I got like hundreds of questions, you know, sent over by real, you know, real candidates, and, you know, there was no question asking, you know, the interviewer asking what is name node or what is data node or what is Hadoop. You know, some blog posts even answer the question, what is Hadoop? You know, no one is asking those questions, right? Because those are not real world production problems. That's why, you know, that's why the interviewers don't focus on those questions. And that's why we focus on those production problems, right? Because that is the problem that is important to us. You know, that is the problem that is important to people who are working in big data projects. So what do we teach? You know, as you saw here, right? We focus on the real world production problems. Actually, most of the things that we, you know, that I shared over this past hour, you know, we cover in our courses, right? I cover in our courses. So we focus on real world problems. It's not theory that's going to help you, right? The things that are going to help you is when you understand what are the problems you see in real world and how you can address them. Okay. So the next thing is our free courses are better than others' paid courses. Okay. So, and I can say this with confidence, right? Because we have heard so many good things about our free courses, and people comparing our free courses with others' paid courses and saying our free courses are the best. Okay. And you probably got a glimpse of that in the webinar, right? Because we're not touching things on a very high level. We want to go deep, and we want to share you know, what is behind the scenes. You know, most of our content in our courses cover behind the scenes details, right? Sometimes we look at the code of Spark, the source code of Spark. Or sometimes we walk you through what really happens in the shuffle, like internally, what kind of objects are created. And some might think like, I don't really need this information. For that, we would say you would need it, because when you're dealing with a production issue, that's exactly what you need, right? And that's where we focus on production problems, and that's where our focus is. So our primary goal with what we do with Hadoop in real worlds is to give you the confidence you need, right? Not just interviews. Interviews is just one part, right? I'm sure you're going to get the job that you want, right? You're putting in a lot of time. For some of you, it's past midnight and you're still here, right? You're putting in the time. So I'm sure you're going to get it, right? But we need to prepare you. Our goal is to prepare you to get that job. And also after you get that job, how are you going to do well in that job? What are the issues you're going to see from day one, and how you can be well equipped to deal with those in day one, okay? So that's what we do with all our courses. If you have any questions, you can type in right now, and then I'll try to answer the best I could. Okay, now you can type in questions that you have. All right, so when we restart a cluster, which service we can restart first? I would first shut down. So if the restart is a two-step operation, right? You're stopping and then you're starting. First, shut down all the jobs, anything that would execute jobs. That is the node managers or Spark cluster, things like that. Let it go down smoothly, okay? Don't let any jobs execute first. Let the jobs that are executing complete, and then turn off the nodes that are responsible for execution. Let it be node managers or Spark worker nodes, etc. Right? And then take care of your data nodes and then your name nodes. Okay? Name nodes, data nodes, and then your name node finally. When you do it, it's usually the reverse. So first you start the resource manager and then your node managers, then your name node, and then your data node, both separately. Okay. Okay, roles and responsibilities. Someone was asking about roles and responsibilities. We did talk a lot about roles and responsibilities and the projects in our first webinar. So I would certainly ask you to suggest you to look at our first webinar. If you go to our YouTube channel, you'll see the first video there, and that's the video you want to watch. Work in a legacy project, and how do I answer for the first question when I try for a Spark developer role? Some people are they don't have a Hadoop background, and I understand you wanted to get into a big data background, right? So what I would usually recommend is first master all the concepts, right? First master all the concepts. Try out projects on your own, right? Try out projects, try to set up a cluster on AWS or Azure, and try to work with a real Hadoop cluster by yourself, okay? By yourself, and try like smaller projects, right? For example, in our courses, we work with datasets like Stack Overflow. We work with datasets like stock datasets. For MLlib, for machine learning, we do things like predicting the election of 2016 and things like that, right? So work on projects like that as you get access to. And once you're comfortable with the tools, take a use case from your existing current project, okay? From your existing current job, and try to replicate that, at least solution it, visualize the solution, and if possible, implement the solution on a big data space on your own, okay? That's the best thing you could do. So when you have hands-on experience, even by yourself, it doesn't have to be, through a job. Even if you have a hands-on experience, just like setting up a cluster on AWS, you will learn a lot, okay? You will learn a lot. So that's what I would suggest. How long will be Hadoop in the future? Does Spark overlap with Hadoop? Well, Hadoop, for example, the HDFS is going to be there for a long time. Yarn is going to be there for a long time. Hadoop MapReduce is phasing out. Okay, Hadoop MapReduce is phasing out. It is being replaced by things like Spark, for instance, right? The NoSQL databases will still have its own role to play, like HBase or Cassandra. Those will have its own role to play. For streaming, of course, you have Kafka and you also have Spark streaming. Those will play a major role. But Hadoop MapReduce will phase out. Yes. Okay. Why do we need three? Okay. Why do we need only three Zookeepers? Is there any rule? That's a good question. Again, we answered the same question in our last webinar. The question was, in an ensemble setup, why do we need number of nodes to be odd numbers, like 3, 5, 7, etc., not even numbers? That's the right question, okay? It's not 3, you can even have 5, you can even have 7, but not necessarily 3, but why odd numbers? We did answer that in our last webinar. Okay. Question regarding the ultimate collection. What if I sign up for this? Do we have time limit to finish all 3 courses? No. All courses are lifetime, okay? And you have lifetime access to the courses, and all the courses are regularly updated, okay? So if you go to Hadoop and Real World /upcoming-releases, you will see the releases or the updates that we're currently working on and what went live and when things are going to go live, right? So big data ecosystem, as you know, it's quite evolving. It changes rapidly. So we update our courses accordingly, right? So when you enroll now, you get lifetime access to the course and all the updates we make to the course. So there is no hurry. You can take your own time, right? Is Java knowledge required? I'm from an Oracle developer background, right? If you know Java, it's good. But we have seen several of our students without a programming background getting into the technology precisely because they know how to work with data, right? They have some kind of data experience, like they worked with SQL, for instance, right? So if you know how to work with SQL, you can certainly work with Hive. And also Spark SQL, and there's a module called Spark SQL inside of Spark. And technically, you don't need to know either Java or Scala to write it. Although you will be writing programs, right? But you don't have to be an expert in Java or Scala to do some basic stuff in Spark. If you know SQL, you can go a long way. Okay, so I have all 3 courses, but I need Spark by Python. Any plan to launch since I'm not from Java background? Okay, so Spark and Python, not now, because this year, as you know, we put in a lot of time into our Spark courses. We have one more update to make on our Spark courses this year. We are doing a full-on project with the Stack Overflow datasets and using Elasticsearch and Kibana. So that's going to be our next update for the Spark Developer and Real World course. And next year, we want to focus a little bit on the developer and admin courses as well, because people have been asking to add some topics onto those courses. And after that, we'll definitely come back to Python. And Mukesh, you're not the only one who's asking for it, but we'll certainly come back. Okay. Okay, so if I add column to Hive table to existing table, after refresh in Impala, it's not showing new column and giving an error. Okay, so this is more of a troubleshooting related question. What I would recommend is, send us an email with what you did, what you tried, along with the error, and we'll see whether we can help you out. Again, each error could be different because your infrastructure is different, your setup is different, so it could mean a lot of things. Okay, but certainly, so, send us the error. We'll be happy to help you out. During course creation alone, could we have integration with cloud computing? Could we have integration with, example, AWS? Okay, so when you enroll to our course, I think you're asking about cluster access. We have a separate cluster for Hadoop, for our Hadoop courses, and we have a separate cluster for Spark courses, okay? So when you enroll in one of our courses, you would get a free access, a lifetime free access to our 3-node Hadoop cluster if you're enrolling in either Hadoop Developer or Hadoop Administrator in Real World. If you're enrolling in our Spark Developer and Real World course, you'll get access to our Spark cluster. Okay, so that's both clusters are co-hosted on AWS. Okay. Is the cluster access lifetime? Yes, it is lifetime. Do you plan to have something for Kafka? Okay, so we have Kafka in our courses in both Hadoop Developer and in Spark. Okay, it is not a full-on course, But we have covered a lot of topics though, right? The Kafka chapter in Hadoop Developer course covers a lot of topics, and in the Spark course we also use Kafka with Spark streaming. Okay, I certainly recommend you take a look. But as I said, our focus currently um, is to update the Spark course this year and updates Hadoop Developer, and I enhance Hadoop Developer and Hadoop Administrator next year. But we'll certainly get to it. Okay. Yes. So Anjana is asking, I did not see latest updates or addition for the admin course. Any plan to add some more? Yes, certainly in the beginning part of the next year. Yes. Okay. Okay. And a question passed my eye. The question was, how do you plan a Spark cluster? Do you have any Excel, like a formula to do a Spark cluster? There is no such formula to do any kind of cluster setup. There are some guide rules which you can use. I mean, no one can really say without understanding your infrastructure that you would need a 10 node cluster and that would solve all your problems. It's just not going to happen like that, right? It is case by case basis. There are some guidelines as I suggested, right? So for example, for each CPU, you need to plan like 2 to 3 Spark tasks. That's a good guideline, right? So you can use such guidelines to plan your cluster, but there is no such Excel file where you can put in certain things and it will tell you exactly what you need, because it depends on a lot of factors, like what kind of files you're using, how are you using it, is it execute intensive or storage intensive? There are a lot of things that play, right? There is not a short and sweet answer for that. Any plans on Spark ML as a separate course? No, we don't have any plans to make Spark ML as a separate course. It's going to be part of the Spark Developer and Real World course. Do you teach Spark ML? Yes, we do. We do have Spark ML in our Spark Developer and Real World course. Yes. Okay, so Kalyan has a very good question. With the advent of cloud service providers like Azure and AWS and their own solutioning, will things like Cloudera, Big Data, will they sustain? I think they would sustain, right? For one, the landscape will be slightly different because, as you know, Cloudera merged with Hortonworks, right? So the landscape could be different, but there will be someone to support these platforms. Because even if you look at something like ADLS, for instance, right? I'm sure the technology behind that is something very similar, even the implementation details, right? Very similar to a DataNode, name node concept, right? So these concepts are certainly going to come from the open source community, and someone has to support it. And of course, these cloud providers are going to enhance it and make it and call it their own. That is certainly going to happen, right? But it's not like the open source community will totally go away, because Cloudera and Hortonworks are basically packaging these open source products into an enterprise supportable solution. That's all they're doing, right? And the cloud service providers are no different. They are basically enhancing open source solutions and make it better, and giving a different name for it. When the solutions which are already doing a better job in the market, like Spark or HBase, you will be able to easily transition into any of the tools that are provided by Azure, AWS, or Google Cloud. Okay. Okay, so if I purchase the courses, how long will you help us on problems? Like forever, Sai. I think that's the answer. So do we support? We don't see like, is the student new, and then only we're going to answer. We just answer. If you ask a question, we just answer. We don't look at the backgrounds. Mukesh is saying, thanks, I've gone through many other courses, but your teaching style is totally amazing. Clear and crisp stuff. Thanks for amazing course. Thank you, Mukesh. You made our day. Reviews like this certainly help us. Certainly. Thank you. Thank you. Thank you. Okay. I'm just going over okay, we have 50 more messages, guys. Wow. All right. Okay, so I think, okay, so we are at 11:40 right now. At this time, I think we should close it. If you have a pressing question which you absolutely need to have an answer, certainly send us an email. But it was absolutely amazing doing this webinar. My voice is almost out, but it was absolutely amazing doing this webinar. We love doing these webinar, and certainly, guys, always keep in touch. Our email is info@hadoopanrealworld.com. Feel free to say hi. All right. Thanks, guys. See you, and enjoy the rest of the weekend. Okay. Thank you.